Assalamu alaikum and good day everyone, because we are having this seminar in various parts of the world and there will be various time zones, so it's a good day for everyone. Since today's topic is relevant to life extension and life extension for civil buildings mainly. However, I would like to emphasize life extension studies are part and parcel of all kind of industrial or engineering disciplines. Like there are normal saying, like when Eiffel Tower in France would be demolished, or when Chicago Bridge in US would be put out of service. So there are challenges, and if we see around, there are basically refineries, fertilizer plants which were operated for 30-40 years in Europe or Canada or America, then brought back to third world and they're still in operation. We have one refinery in Fujairah here in UAE which worked many years in Europe and then last 25 years they are operating in the UAE. We have one refinery Babco in Pakistan, similar basically history. Similarly, there is one Angro fertilizer was also brought into basically Pakistan from other areas and being operated. So I'm just trying to explain the background. It is a normal practice to extend the design life of the assets. And why? There is a reason. Like when facilities are being designed, there is a question of design life. Like, okay, these facilities are designed for 25 years. Whether after 25 years the life of these assets will expire, or we have to demolish those assets, or we have to build new assets, those are the questions to the professional engineers to make decisions. The answer is no. Design life is based on the limiting components or bottlenecks or the area or the components of the facility which may get retired, or maybe they may have certain damage mechanisms active, and because of those defects caused by the active damage mechanism, we may have to replace those components. But if we replace those components, the life of the whole facility can be extended further. Like in a turbine, or in an engine, or in a pump, if any weak component, like even starting from casing to impeller, impeller to bearing, bearing to other parts, if those parts are replaced when their basically good life is expired, so then if we replace those parts, then the life of that particular equipment can be extended further. So in book term, the definition of basically service life, I can go by the slide words. Service life of a building, component, or a material is a period of time after installation during which all the properties exceed the minimum acceptable values when routinely maintained. And these are basically three type of service life: technical service life, functional service life, and economic service life. Technical service life is the same as we normally design. When the building would be able to serve the life as it was technically accepted. Functional service life, it goes if the functional expectations or functional load of the building or a machine are changed. What would be the next life expectancy from the same building or a machine? Similarly, economic service life is a question like when economically viable. For example, if repair and replacement or the refurbishment cost become more than the advantage or the revenue coming from the normal operation of a building or a equipment, then it's better to replace. Or otherwise, you can extend the life by doing the required refurbishment activities. So service life extension overview process. The service life extension methodologies have application both in design stage of a structure or a building or in the operational phase. During design phase, certain parameters are established such as selection of water cement ratio, concrete cover, and admixture etc., which plays a major part in extending the service life. During operation phase, Preference is given in establishing inspection and maintenance strategies with respect to life cycle and cost analysis. Service life design include the following: architectural design and structural design, selection and design of material, maintenance plan, quality assurance and quality control plans for future structures and modifications. Nowadays, for the surface foundations or piles, there is a technology of cathodic protection. If you apply that, it can also help to extend the life of the steel members or bars which are used in the piles or the foundation parts, and it can be used to extend their life further. Information required for predicting the service life: the following four major areas: present condition of the concrete, rate of degradation, past and future loading, definition of end of life. Based on remnant life predictions, economic decisions can be made on whether or not a structure should be repaired, rehabilitated, or replaced. To predict the service life of concrete structures or elements, end of life should be defined. End of life can be defined using below criteria: structural safety is unacceptable, severe material degradation is taking place, maintenance requirement exceeds the available resources, or too much maintenance is coming out of it, aesthetic become unacceptable, functional capacity of the structure is no longer sufficient for a demand. Essentially, all decisions concerning the definition of end life are combined with human safety and economic considerations. Like if we see around us, like if you go to Europe or France, especially UK, you will find many buildings, many palaces are there since 18th century, 19th century, in the beginning of like 20th century and now 21st century. And they're able to maintain those buildings for so long time because they are able to provide required maintenance and they're able to maintain the aesthetic sense. However, if we see normally in UAE, especially in Abu Dhabi, many buildings are being demolished after 30-40 years. And one of the reasons which is being given to us, since the Abu Dhabi is island and there is a sea around it and water table of the sea is high, which is causing more corrosion to the piles and the foundations, and that is normally a threat. And normally the height of these buildings is more than 15 or 20 story. So they feel there is a risk of failure, and that's why preventive measures is being taken to demolish these buildings. However, if a new technology on like cathodic protection and other measures would be taken, then life of these buildings can be extended further. Factor controlling service life. See, as we see normally, it goes from a car or a cycle or to any asset what is under our control or as a normal engineer. So we have to see past and current design and detailing of structures, aggregates or materials used in the concrete mix, field practices involved with placing of concrete, consolidation or vibration methodology adopted during placing of concrete, curing of concrete, in-service stresses induced by degradation processes and mechanical loads, environmental factors. So these are normally the focus is mainly related to the civil buildings. The relationship between durability and performance of concrete, if we wish to see. So there are major four areas accordingly: the structural design, the form, the different type and detailing, then materials like concrete and reinforcements, execution and workmanship is also very important, then curing, moisture and heat, and then accordingly how these mechanisms are being transformed into the future, like concrete deterioration, physical, chemical and biological, reinforcement deterioration like corrosion, and then further performance in terms of resistance, safety, rigidity, serviceability, service condition and appearance. So these all activities of the life extensions are properly controlled, and there are basically industrial standards which are being used. There are standards which are coming from America and standards which are coming from Europe. Both are equally acceptable, and we are used to work with a combination of both, or sometime by using either side. Like from US point of view, ASCE 1199 is a major guideline for structural condition assessment of existing buildings. And similarly, under ISO 15686, building and construction asset service life planning. So there are various standards are there, but normally we cover it under two main. And similarly, there is also ACI, American Concrete Institute 365, reports on service life prediction. So these are properly regulated, and all these steps are being taken in accordance with the applicable regulatory requirements, and then life of these buildings is extended. It should be remembered because the people are living in these buildings. So if any building may collapse, God forbid, then there's a huge life risk is there. So to avoid that, so this is a properly regulated action and being done in a proper way. So under ASCE 11, if you see, the mechanism is quite clear. It's showing you like structural, first is the assessment procedure. So it means what procedure approach we need to follow, it is given there. Preliminary assessment, detailed assessment, both are there. Then structural material assessment, purpose and scope, condition assessment of structural concrete, condition assessment of metals, condition assessment of masonry work, condition assessment of wood, and there are references what should be used, then tabulation of test methods, supplemented references. So what destructive and non-destructive tests which are required, there are many tests which are applicable to see the condition of the assets and their bondings and concrete, those has to be referred. Then evaluation procedures and evaluation of structural members and system is also there, like evaluation procedure, evaluation of structural concrete, evaluation of metals, and so on. So in a way, if there are newcomers as a part of the audience, so it is not like Velosi is saying or we are saying it should be followed. Rather, it is properly documented, and as a part of documentation, like if you see Structural Engineering Institute, American Society of Civil Engineers, so they have properly regulated this part of practice, like how the life of the existing assets can be extended. Second standard, which is coming from America, if we see it, similar approach, buildings and constructed asset service life planning. So since standard coming from two different continents, so their approach or wording could be a little bit different, but normally, as people say in our world, American standards are more easy to follow, and similarly, the little more complicated approach coming from Europe, but both are equally good, what we would say. If we see here, the service planning and step in the design process, the brief, the conceptual initial design, detailed design, and then maintenance plan, performance requirement and accessibility, service life forecasting, introduction to forecasting, issues that can be affecting forecasting, the type of data used for forecasting, then service life prediction based on exposure and performance evaluation, use of predictions based on exposure and performance evaluation, steps in the prediction process, factor methods for estimating service life, outline of factor method, use of the factor method, the preference use reference service life. This is also important, like if one building is able to stay for longer life, why not the other building? The modifying factors, assessment of components and assemblies, then financial and environmental costs over time, general. So then life, basically cycle assessment, life cycle, costing, and so on. Then obsolescence is also there if something is getting out of date or so on. This is ACI, the American Concrete Institute standard, and this is also covering more or less similar approach. like chapter 1 introduction, and next chapter is environment, design and construction considerations, then in-service inspection, condition assessment and remaining service life, then chapter 4 method for predicting the service life of concrete, then economic considerations, and similarly other chapters aging, ongoing work and needed developments and references and so on. So the purpose of this message, what we're trying to convey to the young engineers, like it is not difficult to extend the life because it is a well documented approach and which is well accepted across the globe. Data acquisition and management, which is like one of the steps as we go down. Availability of as-built drawing, previous analysis report and models, geotechnical data, inspection reports, both NDT and destructive testing as well. In concrete, NDT is less non-destructive testing, but destructive testing is more. I will be showing the detail of the test in the coming slide. For all the structural elements, column, beams, slabs, footings, etc. Detail of previous modifications contributing to load increments. Details of other modifications carried out till date. Design basis and specification used for that particular building. Applicable industry softwares. There are many softwares available, but like where we are able to follow generally, Staad Pro software and Live 365 software and in-house Excel spreadsheets also. So these are the three areas, two software and third is Excel spreadsheet Velosi is able to use. Now, flowchart for structural assessment and evaluation procedure for existing building as per ASCE 11. So we can see it like planning for the assessment, preliminary assessment. It's the same like as we went through the index of these standards, but like a sequence is shown. First, the preliminary assessment, then availability of documentation, site condition status, site inspection, materials assessment, preliminary analysis, then preliminary evaluation, then examination phase, judgmental phase, cost impact study, like what is required to be done, then sufficient information or insufficient information. If sufficient information, then we go for recommendation. If insufficient information, then detailed assessment, further documentation review required, building inspection required, again, like because the above information was not enough, so we have to go in more details. Then detailed evaluation, examination phase, judgmental phase, and cost impact phase. Those things would be basically revised and accordingly sufficient information available, and we will be able to make the recommendation and the report preparation. So this is like a flow chart showing Velosi in-house methodology for concrete condition assessment, what we are used as a modified version based on the above standards. So in a way, if you see, approach is same: collection and review of drawings, site visit for condition assessment, then identification of defects and damages. So this identification of defects and damages coming from photography of the defective locations, marking of defective locations on drawing, assignment of the tags, because sometimes we don't know what is what, so it's better to have a proper tracing and tracking of those all components of the building. Then preparation of asset register, then identification of testing locations and concrete testing. So this is important. There are many tests, but there are some are identified here, like depth of carbonation, half cell potential survey, hammer testing, dust sampling for acid soluble chloride contents, and concrete core cutting for compression tests, window breakout, and once these tests are there, the result would be taken, and then we also provide RBI based FMEC analysis, then development of Whale CMS software, and then observations and recommendations we are used to follow. So I have completed up to this section. There are some of the pictures of those defects, like pictorial defects, if we see. Pictures, for example, if you see here, mapping of the cracking, then there is a delamination of concrete caused by corrosion of reinforcement concrete. So if you can see it, this is one kind of defect. Then if you see here pop outs, like it's a part of the concrete is coming out of a basically concrete pattern. Then freeze thaw damage on concrete wall, if you can see it. These are some of the defects which could be assessed and where sampling is required. So method for calculating remaining service life, my colleague Mr. Dijan would be taking over from here. And Mr. Dijan, are you there?
Yeah.
Yes, please start from here.
So we'll stop sharing and you can share from your side. Okay, Dijan?
Yeah, sure.
Yeah, you can share now.
Is this visible?
Yes, just make it full screen.
Yeah, hi.
And Dijan, once this methodology would be completed, before you start the case study, we'll be taking the question and answer those questions jointly.
Yeah, sure.
Thank you.
So methods for calculating remaining service life. Basically, we are following two methods here. One is as per BSc and ISO 15686 code. And the methodology used in this code is factor method. And there is another software that we will be following for the same purpose is Life 365. This is service life prediction. That's a separate software in which we can get the service life, remaining service life, and we can estimate the service life based on the test results like the chloride concentrations. Generally, there will be dust sampling that will be done as part of the assessment, and from the assessment reports we will be getting the dust sampling. Dust sampling will be used for checking the penetration of chemicals such as chlorides, sulfates, carbonates, etc. into the concrete. So once these chemicals penetrate into the cover and once it reaches the reinforcement, it will start corrosion, and then the structure will start showing its distress or degradation properties like kind of spalling, and properties, the steel rebar will start corroding, and the bulging of rebar will take place, and then spalling, etc. will take place. And further, when the reinforcement reaches its threshold level, then the structure may not be able to take the loads, and correspondingly, we may have to see for the, before that, we have to see for the options, like if there is any distress available, like kind of the cracks available on the structure, these would be identified during the visual inspection phases. That is generally part of a regime, inspection regime for various clients. So they will be taking, monitoring these things at regular intervals. And once there is some serious kind of damage or the crack width exceeds the permissible limits set forth in the design codes, then we may have to look into detailed condition assessment, and subsequently based on the NDT and DT test results, we will be going for the assessment in softwares and using the factor method as per BSc and ISO 15686. So as per the code, there are certain terminologies that we need to follow. One is service life. So the period of time after installation during which a building or its parts meets or exceeds the performance requirements. Then we have reference service life, estimated service life, design life, forecast service life, predicted service life, and residual service life. Reference service life is the life that a building or a part of a building would expect or is predicted to have in a certain set. There is a reference set or in-use conditions. That's a reference service life. Then estimated service life would be expected to have, the life a building would be expected to have in a set of specific in-use conditions, calculating by adjusting the reference in-use conditions in terms of material design, environment, and use and maintenance. Design life is the expected service life intended by the designer. Then forecast service life is service life based on either predicted service life or estimated service life. Like we'll have these two service lives, and from that we'll take the forecast service life, comparing both of those. Then predicted service life is the service life predicted from recorded performance over the time, and residual service life remaining at a certain moment of construction. When we check the service life, then what is the life remaining after that particular point, that would be considered as residual service life. Now, if we move on to factor method, there are certain steps to be followed in this factor method. So there are various degrading agents that will act on the structure, and that would cause continuous degradation since it's put in service. Like there will be mechanical agents, electrochemical agents, thermal agents, chemical agents, biological agents. And there are certain other factors that decide on the quality of the structure or performance and the soundness of the structure. Like once we pour the concrete, how we cure the structure, how we cure the concrete, and what is the water cement ratio used, and what are the admixtures used. These all things contribute to the overall life of the structure. So there are certain criteria that we set forth or that we set during the design phase, and once the structure is in service, we will be having certain criteria to monitor the structure and to take it further to its intended design life. And further also we can take, like concrete, generally what happens if the quality of the concrete is maintained well, then the strength wise its compressive strength will increase over the time, since once it is put in use, it will have a long service life, because concrete is going to gain the strength over the course of time, unless creep and other things comes into picture. Then factor method, what we are doing is we will estimate the service life based on certain factors. And these are the agent categories, and there are classes for these agent categories. So this is in reference to BSE and ISO 15686-1. There are 10 parts of this code, ISO code. So 1 to 8 we are referring here. Mainly from 1 and 8 we are taking references for the calculation of remaining service life. So these are agents. Mechanical agents include gravity forces and embossed or restrained deformations, then kinetic energy, vibrations and noises. Electromagnetic agents include radiation, electricity, magnetism. Thermal agents include extreme levels of fast alterations of temperature. Chemical agents include water and solvents, oxidizing agents, reducing agents, acids, alkalis, salts, chemically neutral agents. Then biological agents, vegetables and microbial animals. Now, the performance requirements and acceptability based on ISO 15686 part 1. There are permanent, replaceable or maintainable constructions. So this table depicts the example of minimum design lives of components for particular design life of building based on acceptability for maintenance. This figure is generally used as a starting point for discussion about the appropriate design lives. They should not inhibit choice of design lives for economic reasons. So generally, what is the first column indicates the design life of building. Then the second column indicates inaccessible or structural components. Like if the design life is say 10 years, then inaccessible or structural components should be having the same design life as the original. Then components where replacement is expensive or difficult would also be having design life of whatever design life is set forth in the original design of the building, same should be carried forward, unless there is a small component which can be easily replaceable, like building services, etc. So those design life can be reduced. Then easily replaced components may have design lives of 3 to 6 years even. Then factor method as per BSE and ISO 15687. As per part 8, one specific tool that can be used in service life extension is the factor method, while the application of other possible methods should also be generally acceptable as long as they provide reliable estimations. The factor method is used to obtain an estimated service life of a component of a design object by modifying residual service life by considering the difference between the object specific and the reference in use conditions used which the RSL is valid. Actually, this is kind of a factor method is kind of an empirical formula, and the values would be derived based on the existing appearance and the visual conditions of the structure. So this generally is a empirical method. So in Life 365, we will get to know how exactly once the concrete is put into use, how the chemicals are degrading the concrete and how the service life is coming down. But this is generally, factor method is generally a semi-qualitative method, we can say. Now the factors, there are A to G type of factors that has been categorized based on this code. So A is inherent performance level, B is design level, C is work execution, D is indoor environment, E is outdoor environment, F is usage conditions, and G is maintenance level. So we'll check these factors one by one in the coming slide. There is a separate slide in which I have given what are the values that we generally consider and how we are assigning the values to check the calculations and how we are arriving at the results. So I'll briefly describe what are the factors that we generally consider. Factor A is for inherent performance level, like the grade of the component as supplied, like durables, softwood species. These are general categories only. Factor B would be for the design level, reflects the components installation in the building constructed asset, and it typically based on the level of shelter and protection from agents provided by the design of the building. Then factor C is for work execution level, how the execution of work has been done, what is the quality of the work. Then factor D would be the indoor environment, like if the building is used for a storage purpose or some chemicals are stored inside the building, or if there is any other agents that could cause the deterioration in a faster way. So this would be the factor. This is the factor that that gives the value for factor D. Then factor E is for the outdoor environment, like the exposure to outdoor agents and degradation of the severity. Local level designations can be adequate, like coastal or polluted for this factor category. Factor F is for the usage condition, reflects the effect of the use of building or constructed asset. Then factor G would be for the maintenance level, like it reflects the level of maintenance assumed. For certain components that are inaccessible or require special equipments for access, a particularly low maintenance level should be considered. The expertise of cleaning and the risk of the introduction of agents not normally found, like can also be taken into account. So these are the factors that would be giving weightage in the calculations. Now this is the formula, application of factor methods, like different components will be assessed based on various sections of the building, or like the component wise we will be assessing the conditions, and then we will be, and based on the criticality to the use and cost of the building, we will be assigning the factors. So level of application, the factor method can be applied at different level of sophistication, from working as a simple checklist to a complex calculation. The level should be selected taking into account factors such as actual purpose of the estimation, type and quality of available data and methods. So on this level, the estimation of estimated service life should be carried out by multiplying the value of RSR by, like this is the empirical formula that we use. TESL is the estimated service life. TRSL is the reference service life, and this reference service life is getting multiplied by the factors A to G. So factors 5A to 5G are factors related to each category, which has been mentioned in the previous slide. Theoretically, for the factors, theoretically a numerical value factor can have a value between 0 and infinity, but it should be realistically have values close to unity. So preferably what we do is we'll take factors based on the condition assessment 0.8 to 1.2. But to get a more preferable value, code suggests to take the value in between 0.9 to 1.1. 0.9, 0.91, 0.95, 0.97, 1, 1.01, 1.05, up to 1.1, we can take the values based on our condition assessment and judgment, visual inspections, based on these factors. So now the confidence of estimated service life. Generally, we calculate the service life here, and we will assign a confidence interval, like plus or minus 5 years. Like the confidence of estimated service life for each ESL value estimated, a confidence interval should be estimated as well. So ESL equal to 25 plus or, for example, 25 plus or minus 5 years. So where plus or minus 5 years is a confidence interval. The estimation of the confidence interval should be based both on the confidence of data used for the estimation of the value of the ESL and on the estimated inherent uncertainty in the procedure for estimating the values. Like if there is an uncertainty in the procedure, estimating procedure, then we can have weightage approximately so that we can get the value in a suitable range. In the case using the multiplication level approach, this should be determined by using confidence intervals for the variables of factors included. This can be calculated as per the below formula. Like delta T ESL is confidence interval, T ESL is estimated service life. Then we will take delta RSL, like reference service life and like confidence, the reference service life and the estimated service life. The interval for, like here if we see TESL is calculated considering 25 years as the base level, and there are certain factors, 1.11, 0.951. So we are getting, as an example, we are getting a estimated service life of 25 years. Then from there, we'll consider the confidence interval. So that estimated service life 24 will be multiplied with the factors, change in RSL, like 5 years is the expected period, and with respect to that, TRSL, reference service life, would be taken, and the factors, overall weightage of the factors are also multiplied, and square root of the value is taken. Correspondingly, when it gets multiplied by the estimated service life, we will get the confidence interval. Now, this is the second method, Life 365 software. Generally, Life 365 software uses chloride contamination of concrete to allow the remaining service life based on initiation and propagation period. There are two periods, like initiation and propagation. Once the structure is put in service, the chemical agents from outside will start to attack the concrete from outside. Once the passivity of the concrete is, once there are pores or micro cracks there, then the agents will start propagating into the concrete. Once it covers the, once it reaches the total depth of the cover, then it will have a reinforcement available for attack. So these chemicals will start attacking the reinforcement. Once the passivity of the reinforcement is lost and the chemicals start attacking to the surface, then it will start forming rust, and it will start bulging out. So this bulging could cause the crack formation, tension cracks will be, or the cracks will be formed on the cover surface. Once this reaches an unacceptable level, then the spalling will start taking place. Once the spalling is kind of a last phase, like the rebars are kind of completely attacked, and the rust is formed, and the volume increases considerably at that period. So what we are considering here is, we have to consider the initiation and propagation periods, then year of construction, temperature variations, and depth of chloral intrusion. These are the inputs into the software. So the rebars are epoxy coated, so that there is a separate section drop-down menu in which we can give this input also. The method we generally follow is ASTM C1556 method. In this method, we can give the maximum surface chloride concentration values and time to build up to that maximum. So measured chloride content as per NDT results, there will be dust sampling would be taken as part of the assessment and inspections. So those samples which are collected would be sent to the labs, and we will get the test results. How much is the, like, there will be 3 depth increments generally, like 5, 10, 15, or 25, 50, 100. Based on the requirement. So these 3 depth increments will have chemicals. If they are getting intruded into the concrete, we'll get the results from these. There will be certain concentration of the chloride would be given as a percentage of weight of concrete or percentage weight of cement. So these 2 value input we have, and we will be using this input value with the corresponding depth increments in the, so we will be feeding it in the software, and we will be doing the assessment. One limitation of this Life 365 software is that we will be, as part of the assessment, we will be getting the chloride cover also. So cover of the concrete, if it is more than 55, suppose, then there is a limitation in the software to feed the cover values more than 54.5 mm. So what we generally do is we'll take some intervals like 30, 40, 50, 54, or we can divide them in small batches, and we will take the values corresponding to that, and we will get the results. And from the available results for the values lesser than 54.5, we can directly get it. If the cover value is exceeding the 54 limit, then we have to extrapolate the value which is obtained during the covermeter survey, and we will input the value which are available, and we will perform 3 steps, and we will take that results and we'll extrapolate it to the cover value which is more than 54.5 mm. So that is one of the limitations of this software. If the cover value is more than 54.5 mm, we have to extrapolate the value and do the assessment. So the input would be generally, we'll be having the average annual temperature for a particular site, and monthly we have the range values. So this is one of the input. Then we will get the chloride concentration with respect to the depth range. So this is another input. These values we need to give as input before doing the assessment. I will show you the slides, the screenshot of the software in which we need to input these values. Now, once we input the value, the software will generate a graph showing what is the surface concentration and what is the maximum year at which this surface concentration will be achieved. And from 15 year onwards, it is getting a straight line. So maximum surface concentration has been obtained after induction into 15 years. So this is a table showing the extrapolation for this method. 54 mm is the available cover range in the software, and 78 mm was the requirement. So what we did was we did covers for 30, 38, 46, 54, then extrapolated similarly to the required depth range. And time, there are time of initiation for in this table. First table is showing the time of initiation with epoxy sealers and without epoxy sealers. Epoxy sealers will have passivity along the reinforcement, so it would have certain more resistance towards the chemical attack. As you can clearly see, for 30 mm, 14 years is with epoxy and 11.7 years for without epoxy sealers. Then once we receive these values for 78 mm with epoxy sealers, time for initiation is 23.7 mm. So from this value, we will have final value for remaining service life deduction. This will be done as a separate check in an Excel sheet. So we'll have the location, which sample it was taken. If it is for a column, then we'll have separate check for the column. For beam will be separate. For foundation should be separate. Then time of initiation we'll have with epoxy sealers, and there will be certain reduction like 0.8 T1 for kind of any special for special type of concrete, or if we feel that this can be reduced to 0.8 times. Then time of progression will also be available from the software. So we'll take those values and we will get the total service life. So total service life is 24.96 minus 23.7. We'll get remaining service life as 1.26 years. I'll give the details in the forthcoming slides. Now we have the case study. This is for a substation building. So this I'll present.
Hi, Digit?
Yeah.
So before we move forward with the case study, let's do some Q&A. Yep.
Yeah, sure.
There are questions, right?
So I'll read the question. So one question we received, is there any data structure in UAE that says that building should be demolished after 30 years of life? Are you aware of anything like that?
No.
No, there is a general convention, but the life is also being extended after 30 years also. But there is checking, and there's a requirement of rehabilitation. And maximum, as we see, this life is being extended from 40 to 45 years.
Okay.
So there is a mechanism through municipality, and same is in Adnoc, like work where we have done, and the substations were built in 1977. So it means the life of these buildings were already about 43 years old, right? And now being extended to almost 60 years. So the life is being extended, and there is a criteria based on the same international standards.
Aesthetics will add to this, like if
Yeah.
generally if the aesthetics of the building that is present in the city, which municipality want to change the appearance levels, then maybe they will consider demolishing some of them if it is built 30-40 years before.
Yes.
Okay, next question. So in case a third-party structural audit confirms a particular structure is still safe even after completing the service life of 30 years. But as per the design life, the same has to be replaced with a new structure. So in that case, what suggestion can be taken? Is it worth taking the risk to allow the structure to be left untouched, or should they proceed with the design life?
No. Design life is not a criteria to demolish the building. Design life is the initial, and there would be a limiting component in the design basically basis, and the life is extended based on the actual. There are steps, 8 factors, and those all factors are being analyzed, and then the next decision is being made. If we have to go only by a design life, then every building should be demolished after 30 years or so.
Okay, next question. What is the NDE method commonly done to check the concrete integrity, and what code is governed to this NDE?
So it's not NDE, it's basically in the concrete case, mostly are the destructive testing. Dijan, please correct me if I'm missing some point. At least there are 12 standard tests, and there are many more also, like breakout of the windows, dust sampling, then chloride testing. So, Dijan, you may add those tests you might be remembering.
Yeah, generally for concrete, what we do is we'll take out the core samples. We have this is destructive testing. We'll take out the core samples and we'll test it at the labs. So compressive strength of the structure would be available. Then we'll, for checking the rebar conditions, we will take out the window. Window will be opened. A small portion of the concrete would be exposed, and the reinforcement would be visible. And we'll check the potential of that. There is a method, half cell potential is there. So based on the readings, we will come to know if there is any corrosion in those. This is a connected structure, like rebars will be connected. So from the readings, we will be taking the half cell based on some of the windows only. So based on that, we will get to know if there is any reinforcement happening onto the rebars. So mostly for concrete, we'll do. Then UPV is there, ultrasonic pulse velocity test. Then rebound hammer is there. These are non-destructive tests. Using this also we can check the integrity, like the velocity would be available based on the UPV, pulse velocity. So from the velocity with which it is getting distracted back to the probe, it will be considered, and the ranges would be tabulated, and corresponding to the velocity value, there will be specific values based on the ASTM codes. So if the velocity is within this much range, the quality of the concrete can be considered as excellent. If the velocity value is in a lesser range, then the quality would be considered less good, or likewise we can designate and we can get the property, like the condition of the structure, concrete generally.
Next question is, what is the acceptance deviation or tolerance limit in percentage terms with respect to the estimated service life versus the reference or the design service life, or let's say a marine structure, such as a jetty trestle, as most of these structures have a life of, let's say, 25 to 30 years.
See, for offshore structures, there is a separate mechanism which is API 2A or API 2A. Then other extended standards are there.
BS
Yeah.
49.
And in the offshore structures, there are 4 kinds of analyses which are run: pushover analysis, fatigue analysis, in place analysis, and as a result of these analyses, the decisions are made based on actual condition of the structural members, their basically piles, and flooding members, whether life could be extended or not. As long as concrete aspects are concerned, which are coming near to jetty, and then there is also impact of how effective is the CP system there, what the condition of those particular concrete members, and then the same 8 factors approach is applied there. Other part is there's a confidence factor as well, like if based on the factors we are extending the life, let's say 30 years, but the confidence factor may help to decrease it further by 6 or 8 years. So there are the factors which are considered as a part of the decision-making process. Dijan, you may add further if you require.
Yeah.
So, next.
Okay. Next question. For concrete testing, what are the measures which ensures that no impact on the strength of the concrete while testing?
There are basically the threshold values during the test, if the results are within acceptable range or not in acceptable range, right? If the test would show a negative result, then there would be either a repair or replacement requirement, demolishing requirement, or we can maintain as it is. Dijan, you can add
Yeah,
some more example here.
for the there are two types of testing that we generally consider. One is destructive testing, another is non-destructive. So destructive testing also, if you are considering sufficient like measures are taken to not damage the strength of the structure. Like generally what we do is we will take samples from where there is no existing like if there is any conduit or something is passing, or any major main reinforcements are getting damaged, those things we will not take. What we do is we do the cover meter and we will identify the rebars at those locations, and we will take the core from those locations. So once we are taking the core and we are replacing it with the proper material, then there will be no issue. If client is concerned about the destructive test, then we can use non-destructive methods like half cell like UPV. UPV you kind of good quality results. Rebound hammer is generally somewhat, some of the clients are not specifying rebound hammer. So UPV, ultrasonic pulse velocity, would be a good alternative if destructive
Right.
testing not to be done.
Okay.
Okay, somebody is asking about the softwares which are applicable again. Maybe if we can go back to that slide and just.
FE is not applied on it. There are two softwares we referred. One was Staad Pro, other was 365, right?
Yeah.
Next question is. Yeah.
So they're asking about the depth of chlorine intrusion. Can you just explain a little more detail about this?
Depth of chlorination is generally the pores micro cracks will be available soon after the concrete is placed and the curing is completed. So passivation of concrete will keep on for further time, but once these micro cracks attracts the chemicals which will be in a highly chemical environment or near to seashore something, these scenarios would be having or if the structure is kind of vibrating equipment foundation, something like this. So due to the vibration also there may be chances of formation of small micro cracks. Through these micro cracks, chemicals would be penetrating into the concrete. So we generally have 50 mm or 75 mm covers for foundation and exterior columns, etc. So once these chemicals penetrate into the concrete and once they reaches the cover, clear cover is been covered, then they will get the rebars. So once it reaches the rebar, it will start attacking the rebar, and this will have considerable strength reduction because of the formation of rust and the bulging. Then subsequently, due to the corrosion, the material volume will start to increase for the rebar, and for this continuous supply of chemicals have to be there. Like if the environment is continuously getting exposed to these chemicals, then only it can penetrate further into 75 mm depths. Otherwise, generally, if it is a normal working environment and a normal structure, this penetration is very unlikely to occur at a faster rate. So this is the scenario.
Okay, Dijan, the two questions I will answer. One is a question coming from Mark Anthony. Whether there's a due approval required from any authority? Yes, there are regulatory bodies which are involved in the process, and the reports are submitted to those regulatory authorities as well. The last question is coming from Nasimullah Khan, is saying whether does earthquake affect the service life of a building? See, all the buildings are designed as per applicable seismic zones, so those are considered safe if any earthquake activity may take place in that particular area. Yes, if post-earthquake, if there's any event or an earthquake happening in that particular area, if there's any effect on the building in terms of crack or any distortion, then reanalysis is required, otherwise it is considered safe. Dijan, you start the presentation now, next case study, and then we'll have a last batch of the question at the end of the presentation.
Okay. So case study.
You go back to your presentation here.
So this is for a substation building. Actually, the scenario was like this. The building was completing its design life, so the client wanted to do some kind of rectifications and take the building into service for another 20 years. So they hired one sub-vendor for doing this assessment and entity test. So these test results were provided to us to check the and rehabilitation was also going side by side. Once they completed this, they asked us to do the remaining life calculation for some of the 6 number of substation buildings. So this was kind of a sea exposed environment. So we done the assessment based on 2 methods, factor method and Life 365 software. Factor method values were validated using Life 365 software. Actually, factor method was applied once the rehabilitation and repair has been completed. Then Life 365 software, the original condition, like when the plan was in service from 1970s. So from that itself, the columns are in place, and only the top cover has been removed and it has been refurbished, and some other rectification methods are also been done on the structure. So this is a scenario. Then this is the index of the report that we presented to client. So there are various factors like code standards. Then there is one analysis part also, which was carried out as part of the feed study. Then factor method, then reference service life was calculated. Then confidence of estimated, like calculated estimated service life and the confidence interval was calculated, and correspondingly the same has been checked with the Life 365 software. Then the conclusions and recommendations were given along with the test reports and data, like the conclusions made during analyzing the test reports and the conclusions made as part of the factor method and Life 365 software analysis. So initially, these number of sample tests were carried out: core compressive strength, UPV rebound, cover meter survey, half cell potential, dust sampling, carbonation depth, and based on the dust sampling, chloride, sulfate, pH, etc. was checked. So the ASCE condition of the structure was inspected as part of visual inspection. Based on the visual inspection findings, locations were identified for taking samples. Then the samples were taken and it has been sent to lab. The results of these samples were available for further analysis and assessment. So this is actually what they did was there was some additional load on coming onto base slab, ground floor slab. So what they did is, as part of the feed study, they have analyzed the building for the additional load to see if it is safe or not. So this has been performed and it was been considered safe. Now this is the condition of the building before and after rehabilitation. Left side are the cracks and all these things. Like the condition of the outdoor environment was also not good. So they refurbished this and it was made into a good condition as shown on the side.
Yes, basically this building is at island, very small island here in Abu Dhabi. We are not disclosing the name of the island, and in island environmental is more basically saltish and wet, and water level is also quite high there. Yes, you can continue.
So remaining life, the report generally contains basis of assessment, then RLF of building component as per factor method, and based on Life 365 software, then assessment of building for current stress levels for change in loading conditions, interpretation of entity of test results, validation of repair or rectification with respect to field drawings, and recommendations for keeping the building in service for next 20 years. So this is the input screen for the Life 365 software. Generally, when we open the software, it will have certain tabs like project, exposure, concrete mixture at the top. So when we click on each tab, there will be certain input requirement. So we can give client name and analyst name, description of the structure, etc. in this, and we can have the width, reinforcement, depth or cover, and total length. So then base year, the year in which we are doing and analysis period, inflation rate and rate discount, etc. is automatically coming. Actually, cost is also a part of cost analysis study is also part of the Life 365 software, but we are not interested in the cost analysis. So moving on to the next tab, it is for exposure. Actually, we can give the exposure value manually, or we can use it ASTM. Default values are there based on the locations, but this software is having locations. The default location is New York, and there are other cities as well. But for the UAE, we don't have the direct location wise, they are not able to take the value. So we add the values manually. So ASTM, we can, once we put the manual settings in the first tab, then we can select the ASTM C1556 and we can add the values. So we can add the temperature values here corresponding month wise. So they will get the graph here corresponding to temperature, and they will show the graph corresponding to chloride concentration. So once we select the ASTM C1556, then we can add new set. So that will be, once we click on the new set value, this window will pop up, and here we can give the depth increment like 0.1 to 50 mm, and we can give the chloride concentration value. These were the values available from the NDT results. So these values were put, and this was added. So the maximum concentration value would be plotted here in the corresponding graph. Now we have the, once we input those values, then we have the parameter, like how for the days and initial concentration. For temperature region of 1 year we are selecting, so corresponding we can days, there won't be much effect, and the initial concentration value would be inputted. Now this is the overall value. There is in the right side panel, initially it was showing the graph, then we have ASTM calculations also. Tabulation is there for the ASTM calculations. Now when we move to concrete mixtures, generally water cement ratio we need to add, then other are kept as default. And here we can, in the right side, steel black bars and epoxy coated rebars are there. So this would be input here. In the next window, see, this is the value for black steel, epoxy coated stainless steel. So these we can change and we can adjust the input value. One will be for base case, and the next two would be for alternate case. Two case we can set the values. If the black steel we can see, and correspondingly for the epoxy coated steel also we can see. Now here barriers we can make the membrane or sealers. This is also one of the alternative for putting the inputs. Now this is the results value. In this, what we generally see is the member value, the member which has been analyzed. It will be shown here in the box square column. Outer diameter 400, cover is 54 mm. The maximum surface concentration is in the middle box, like 0.09% of weight of concrete, and years to build is 15. And then we'll have the temperature, monthly temperature. Based on the water cement ratio and black steel and with the sealer is the alternative case, and base case is without sealer. So it will automatically calculate and give us the values for initiation period of 16.2, propagation period of 6 years, and service life 22 for base case, and alternative case correspondingly the values are given here. The other values are kept as default. D28, M and CT values are kept as default. Now the results and findings. So in factor method, this is the table which showing how we are inputting the values. So inherent quality characteristics, we have inherent quality, A, B, C factors are coming in inherent quality. Then environmental factors are contributed by D and E. Operation factors F, G. In the factor, we'll provide which factor is considered A, B, C, etc. Then factor category, inherent performance level. In inherent performance level, we will have material type and grade and durability features. Design level, we have design consideration, new component added or not. Then work execution level, we have site execution, how the execution has been performed at site, and performance. Then environmental, we have indoor environment and outdoor environment. So ambient condition, how it is governing the assignment of factors. Then temperature or rain or marine factors, that will be considered in properties for factor category for the outdoor environment. Then usage conditions and maintenance levels will also be shown in the table. And correspondingly, in use conditions, we have poor, normal, and good conditions. Based on these three categories, we will give the assign the factors. So we have the site conditions we know, and the work execution and the other rectification that has been carried out are known to us. So based on that, we can assign factors like for the material type and grade based on the design basis and the work executed at site and other quality checklists, etc. We can assign values from 0.9 to 1.1. So those similarly, those values were assigned for different factors from A to G. Minimum value was 0.95 and maximum value was 1.1. So these factors would come in the empirical formula, and we'll do the calculation from there. So this is the estimated service life calculation. So from ISO 15686-8 code, we have the time estimated service life. Reference service life would be considered as 25 years. It was considered, this would be based on the discussion with client and initially how the design criteria is being set between the consultant and the client. So since the building was in operation and it was further refurbished and rehabilitated, 25 years was considered for this building. So when we estimated the service life, it was coming as 24 years based on the factor values which we have tabulated in the previous slide. And correspondingly, the confidence interval was calculated from the formula given in the below section. This 24 years which we have calculated is coming here, then 5 by 25 whole square, and the factors, the difference of the factor values corresponding to total weightage assigned to that value. Difference between 1 and the factor which was assigned. So some of the value would be plus and some of the value would be minus. Like 1.1 would be having 0.1 as weightage, and 1.1 would be the overall denominator for that squaring within the empirical formula. So for 0.95 value, it would be deducted from 1. So minus 0.05 would be the value for this case. If the value is considered 1, then difference would be automatically 0. So there won't be any value coming in this section. So the confidence interval of plus or minus 6 has been obtained. This is the like in the results section I was showing both of the methods. First two are for factor method and the third one is for life 365. Here also the remaining service life is shown in table based on the base case and alternative cases. Now for the study which we have conducted, these are the recommendations, like the health of the asset shall be monitored continuously and periodic inspection plans are to be undertaken to check if there are any damage causing agents are at work on the structure. Then asset register must be prepared and tracking of the asset shall be done using the same inspection. Findings and damage identified shall be logged and should be checked periodically for how the asset is behaving based on the criticality and severity of the exposed environment. During the construction of lifespan of the building, below mentioned points should be taken into consideration. All material specification used during the design must match or exceed the site, like the points which needs to be considered during the repair or rehabilitation, like the properties which were used in the initial construction. If you are going to modify anything, then the properties should be matched and the specs, etc., should be followed typically correspondingly. Then maintenance and repair work should be carried out for any damaged portion during the lifespan of the building. Like if we are finding any damages, then we can take the repair measures and we can do like if the cover is damaged, then we can do the deep screen repair, and if the rebars are in corroded shape, maybe we can consider replacing if the member is not that critical. See, such kind of measures can be taken. Then crack mapping and regular inspection and maintenance to be carried out the building intact for next 20 years. Ambient conditions should be kept normal. So this plastering was not there. So the recommendation was given to do the plastering. Then temporary protection, like if temporary works are done on the structure, then it has to be analyzed before carrying out such works. Then if any dust or environment, if some construction is to be done which produces excessive kind of dust or etc., then proper protection of the critical members or equipment should be done properly. For repair and strengthening of the unreinforced masonry block, it was necessary to perform the strength and bonding test of blocks and plasters before taking a block wall repair. Recommended to check the columns for strength and serviceability before it becomes non-operational. These are the general recommendations. Now, for any repair kind of thing for the existing substation building, following points shall be taken into account, like temporary work shall be designed in detail to withstand the maximum load capacity. Temporary protection shall be done. Block work, if any modification or repair is done on the block work, then it should be properly checked. Then crack mapping, periodic inspection and maintenance are to be carried out. Then roofing sheet, the condition of the roofing sheet shall be checked properly. Detailed inspection shall be carried out on floor slabs, supporting the ground from bottom side. Like if any temporary measures or inspections are to be done, then those should be carried out with proper measures and with the temporary supports, so that the main structural component don't get damaged during this inspection or assessment. Periodic maintenance should be done so that there is no other damage causing component get into the reinforcement portion of the structure. These.
Okay, there are a few questions there. One question is, Gauri Shankar is asking if there is a, for example, if there was extension of a existing building or modification, on what basis you refine again the life of the same building. So it is different question, because once there is extension, it means you are putting the new loads or new effects. The whole building has to be redesigned technically, and then accordingly these factors are applied, and then life is extended for the older part. Dijan, you can add to that question.
Actually, new portions, if it is the column and the foundation are separate, then the new building would be having design life of a new structure, like 30+ years. We can directly assign to those. But for the older structure, if we are modifying the older structure and adding new weights, then initial assessment, condition assessment has to be done on that structure. Then if it is a single structure, and if it is getting extended vertically, maybe we need to do the condition assessment first, and then if based on the factors and based on the NDT test results, we can analyze the same in the software also. If the building is giving results based on the chemical intrusion, if it is not getting affected, and the strength wise also we are getting compressive strength values, NDT based on the NDT test result we are getting compressive strength values, and we are getting the corrosion of the rebars using the half cell potential. So if the strength values are not falling below the acceptable limits, then we can proceed with that. There won't be, like, the building would have the design life based on the actual condition of the chemical intrusion. Like if it is the cover is not getting exposed so far, then there won't be an issue. So we can take the life with respect to the same. This can be checked in the Life 365 software.
Right. Okay. Next question. So let's say the client, in this case, he wanted the extension of the unit by another 20 years. And in case, based on our assessment, it is found that the maximum further serviceable life of that unit is, say, 12 to 13 years. So client is looking to extend it by 20 years, but based on the consultant's assessment, it's 12 to 13 years. So how would one reach to a conclusion, and what would be the suggestion to the client?
Yeah. If some, there will be some, we will do the assessment based on components, like the columns would be assessed, the slabs would be assessed, foundations would be assessed. So if the structure visibly there is no distress, or based on the calculation, if some portion is having less service life, maybe we can consider them rectifying or repairing that section only with like if the life is reduced because of the chemical intrusion and rebar is slightly having the effect, then maybe we can consider if some, like, component wise only we can go. If one of the component only is giving the less life, maybe we can rectify that component and take it further. Like we can do the deep skin repair of the cover, and we can modify the rebars also. We can lab the new rebars, and we can rectify that when that recommendation we can put forth to client also. If it is agreeable to client, we can take the life further. And further, once we agree on this, then we need to put into use the inspection and maintenance plan. Like at regular intervals, we need to see if it is behaving any adversely, or if there is any signs of crack, something. In that case, if it is not giving any distress or something, then we can take it forward.
Yes, one thing is there, if there is any key component or key part of the building, and if like column, if that column cannot be replaced and the problem is with the major structure or rebars of that particular column, then there is no other exception other than demolishing the building. So it's not the case like whatever we do, we can always extend the life of the building. No, in some cases, we have to accept the results and we have to demolish the building if it has reached to the end of life. Okay.
Next question. So they're saying that there are standards and industry standards for life extension of civil buildings, but do you follow these standards when you're designing for mainland, island, or at the bank of the seashore? Is there any such constraint or limitations mentioned in the standards?
No, there are two sets of standards. One is for the new building design, UBC and others, right? Another one is for the extension. So I think that is the question. There is a segregation. There are the codes for new buildings, and there are the code and practices for the which are being used for the extension of the life studies. And like in, I know mainly in the mechanical side, there are ASME codes which are used for design, and there are API codes which are used for the extension of the studies. So same could be the case. Dijan, you can add more.
Generally, there are codes for extending service life extensions, but design point of view, generally what we do is we'll check the current strength levels. We will have the values of compressive strength and values of rebar corrosions. If those values are not...
So Dijan, the question is a reference to the code and standards for new buildings and code and standard which are being used for the extension of life.
They're also asking about like, is there any difference of standards?
No, generally,
mainland.
Yeah, generally there will be a minimum compressive strength and yield strength of rebars and concrete, which would be set forth in the code, original code, as per ACI code or BS codes. So if based on current strength levels, if the strength value is lesser than the original design strength value set forth in the code, then we generally won't prefer. Basically, design point of view, we'll check the strength and serviceability. So there is no separate code from design point of view. There are certain references given in the these codes like ACI 365.1 or BSE and ISO 15686. Either we can limit the strength values to a particular range, or we can follow the original codes only. There is no separate design code for the life extension point.
Okay, the next question is related to if there is any computer integrated technology to ensure the building crack and anomalies like 3D, 2D. According to our knowledge, no, because the buildings are complicated parts, and structure wise, yes, you can do it. Structural, like if you go to offshore structures, 3D models are available, and you can show all the flooded members or defective members. However, in the building side, it looks like to see complete building in a 3D model and seeing its impact in the analysis, it may not be practically possible because analysis is being done on component by component mainly. Dijan, you can add more if there is anything.
Okay, so next question. This person is asking if does clean and efficient energy be considered in service life extension design? Like, will there be a huge difference if they decide to use clean energy compared to the previous typical energy that was being used in the construction?
No,
of the
so
building?
this is a separate question. Clean energy means what? Renewable energy,
Yeah.
or if you want to add more solar basically cells on the top of the buildings, it will add little more load, right? So analysis is possible, right? And you can use alternative energy sources, but it would depend on the size and height of the building and how much extra load that building can take. So guys, this ends our session. Thank you very much for your participation, and we look forward to meeting you all for the next upcoming webinar, and good day for now. Bye bye.